Okay, here we want to add and subtract cube roots, and our process is going to be similar. But what we have to remember here is our list of perfect cubes. So instead of looking at perfect squares, now we need to look at perfect cubes. And we get the list of perfect cubes by beginning with 2 and cubing it. That result is 8. Then we cube 3. That result is 27. Then we cube 4. That result is 64. Then we cube 5. That result is 125. We cube 6 and we get 216, and so forth and so on. And we could extend the list as far as we need to. All right, so the numbers on this list are the numbers we're now interested in. So when I go to simplify the first radical, 4 is multiplied times the cube root of 750. But I am only interested in whether or not one of the numbers on my list divides evenly into 750. And it turns out 125 divides into 750 6 times. So I write cube root of 750 as cube root of 125 times the cube root of 6. Then I see that 64 is actually on the list. So 6 times the cube root of 64 is actually 6 times 4. 4 is the number that cubes to give 64. And then negative 2 times the cube root of 384, it turns out 64 divides into 384. So I rewrite cube root of 384 as the cube root of 64 times the cube root of 6. So now I'll apply the cube roots to the perfect cubes. So cube root of 125 is 5. So this is 4 times 5 times the cube root of 6. Plus 6 times 4 is 24. Minus 2 times the cube root of 64, which is 4. So minus 2 times 4 times the cube root of 6. So 20 times the cube root of 6. 4 times 5 is 20, and that's multiplied times the cube root of 6, plus 24 minus 2 times 4 times the cube root of 6, which is 8 times the cube root of 6. So 20 minus 8 is 12. So if I have 20 cube root of 6's, and I take 8 of those cube root of 6's away, I'm going to have 12 cube root of 6's. And I cannot do anything with the positive 24 except recopy it. And that is my final answer. So in order to add radicals, the index and the radicand have to be the same. 24 is not a radical term at all, so it cannot be added or subtracted with these cube root of 6 terms.